Here is 2.12. See what we have to do here. Let x and y be positive constants. Write each as a single log. Alright, so here we go. Using our laws of logarithms, coefficients become exponents. Log base 2x cubed minus log base 2 of y to the fifth. And subtractions, they become divisions of a single logarithm. So log base 2, now it's x cubed divided by y to the fifth, and we'll wrap that in parentheses. You have to take the logs and say 2 to what power gives you this x cubed over y to the fifth. That'd be tough. Let's see here. Next problem, number 2. Right, it's a single log, so here I've got a coefficient, another coefficient, so that 2 is going to pop up there, and that 1/3 will pop up there. They become exponents. And then we've got some addition right here, and so that becomes a single logarithm, but it will now be a product of that. All those are equivalent. Alright, let's jump to problem number 3. Same idea. We've got though this 1/2 here, and it's outside these parentheses, so we're going to have to distribute it. That's one way to deal with it at least, so we'll do that. That's a half log x, and half of 5 would look like this, half of 5. And then those pop up into the exponent position of their respective logarithms. And then the addition of 2 logs can be brought together as a product. So, and we're done. Problem 4, same thing. We'll take those coefficients to the exponent position. And subtraction becomes division. And there we go. Alright, 5, 6, 7, and 8, we're doing just the reverse of those. Now we're trying to expand them. So I'm going to take the multiplication, change it to addition, and then bring my coefficients, or my exponents out front as coefficients. And there we go. Oops. Problem 6. First thing I do is change this into exponents by taking the square root and writing it as a half power. Excuse me, got a little frog in my throat, and I'm going to raise each of these to the half power, so you have to multiply exponents there. So I'm taking 3 times a half and 1 times a half. The 1 times a half gives me the half, and the 3 times the half gives me 3 halves. But now it's a division, and so I can separate it into a subtraction of 2 different logarithms. And then those exponents come out front as coefficients. Like so. Problem number 7. Very similar to the last problem. Change it into an exponent, and we'll multiply, so it's 2 times this half up here, or half times this 2, I guess I should show it kind of in the other direction. That's half of 2 is just 1, then I do half of this 4, so it's y squared at that point, and that multiplication becomes addition, and the 2 on the y squared will get to pop out in front, and there, log of x plus 2 log y. Problem 8. This one's a little bit trickier. This one is a subtraction inside the logarithm. It's not this. It's not like log. Oops, let me get something right. It's not this. Log 25x minus log. That subtraction is a subtraction of two logarithms. This is a subtraction inside the log. And we haven't seen those before because we don't have a law or a property for it. So what we are going to do here is try to write this as either a multiplication or a division problem or as some power of something with an exponent on it. And the thing I notice is you can factor out a 25 right away. But see, now it's a product of two things inside a single logarithm, and that can be separated into an addition problem. And log base 2, or log base 5 of 25 is just 2. 5 to the second power is 25, so this is what this would simplify down to. And I can't do anything with that x minus 2 right there. It's a subtraction in a single logarithm. If it was a division, I could separate it into a subtraction of two separate logs. Let's see here. 9 and 10 are last two here. Domain, range, and transformation. Alright, so right now if I looked at this function right here, this 9 in here indicates it's going to be a horizontal shrink by a factor of a 9. But usually they're asking not for the dilations like that description is, but try to rewrite it into something that's a little easier to understand. And in this case, you can make that multiplication into an addition. Log base 3 of 9 is just 2. So now this part is just the regular parent logarithm. It just looks like this. Let's grab a color red here for asymptote. And so this is a logarithm, which always looks like this, but it's bumped up by 2 units, which is easier to understand, at least visually, than a horizontal shrink by a factor of 1/9. So that's what we're trying to do in these problems. Our domain here, you don't have to do anything for your domain other than just make sure your argument is always greater than 0 and solve that. So our domain hasn't changed. X is greater than 0 or from 0 to infinity. Our range is always the same thing, negative infinity to positive infinity. Transformation, we call this a vertical translation up 2 units. Please spell all that out. I'll be quick and short like I just was. And then finally, number 10 here. We just saw one similar to this. What you want to do is just kind of rearrange it. I like the x term first. That's starting to look like something we're used to. It's a subtraction. I need to have a multiplication, so I take out a, looks like negative 16 here, giving me x minus 2. And now this little multiplication right here, what I want to do is kind of separate it either mentally or you can do it on paper. You want to treat it like a 16 times a negative 1 times an x minus 2, essentially. And this allows you to go, oh, okay, so this is log base 2 of 16 plus log base 2 of negative 1 times x minus 2. And you want that x minus 2 in there grouped together. Now, log base 2 of 16 is just 4. But now, this part on the inside I can get descriptive with. So this shifts it right by 2, whereas this negative 1 is going to cause it to flip horizontally left to right or right to left, however you want to think about it. Okay, so now we can describe that reflection, and I'm going to draw a quick graph of it so you can see it. So again, normally our logarithm looks something like this. This one is going to be shifted right by 2. Pull that out, right? That's plus 32 to it up, okay, minus 2, yep, shifts right by 2. So now here's my vertical asymptote. but then it gets flipped over, so it gets shifted right by 2, but then it gets flipped over, so now it's going this way. What does that to be in purple there? There's that horizontal flip, and then finally it's shifted up by 4, so now it's this blue color again. Alright, but now our domain, we're going this way with our x's, going to the negative x direction. So we're going to say, hey, domain is from negative infinity all the way up until I get to the number 2. So that's my vertical asymptote. My range, all real numbers. And finally, the transformation. So we'd say reflected over x-axis did right by 2 units and up 4. Right, measurements and up 4 units. There we go. That's pretty darn descriptive. And there is 2.12.